Hello. So, today, we're going to talk about a system of equations with some quadratics. Okay? So, the previous videos dealt with a system of two linear equations. Today, we're going to deal with a system of equations with two quadratic equations, or with one quadratic and one linear equation, as the one on the board shows. Okay? Again, always a good idea to use your graphing calculator. Okay, we can quickly graph these two on the calculator. X squared minus 5x minus 7. And for the other one, of course, we'd have to solve this for y. So I would just add y and then add the 2. So we have like y equals 3x plus 2. And I would just type in 3x plus 2. And you can graph this, and you can see, well, not perfectly. If we zoom out a little bit, hit zoom, and then the third choice, out, and then enter, you would see the parabola and the line, and that they meet at 2 points. Okay, those 2 points are the solutions to the system of equations, right? The solution to a system is the point of intersection on the graphs. In this case, there are 2 points of intersection, so there are 2 solutions. Okay. Now, checking the table once again, we could be a little more clear on those solutions. You can see that where x is -1, you see y has the same value, right? So that is one of our solutions. The point -1, comma -1 is one of our solutions. There's a little note of that down here. The other one, it happened further in the negatives, I believe. No, maybe in the positives. There it is. When x is 9, y is 29 in both of these, right? That's the other solution to the system. So you just want to find where the y's are the same for a particular x value. 9, comma 29. Okay, those are the solutions. And again, you can check on the graphing calculator, you can see that. But I want to show you how to do this algebraically. You will have to show this algebra. Okay? Let me pause the West Philadelphia band, The War on Drugs. That album, Lost in the Dream, is probably my favorite album of all of last year. Anyway, we have, again, a quadratic and a linear. All right, if you're presented with this, you could graph and just check the table so you have an answer sheet right in front of you, essentially. You have the answers. But you'll have to show the algebra here. So in this case, because we have one of the equations in explicit form, right? We have y equals, then you might want to think about using substitution. Okay? Y equals this. And generally, when you have quadratics involved, you will have the quadratic in y equals form. You'll be presented with that. So you almost always will be using substitution when you do these problems, all right? So we're going to substitute this whole expression in for the y right there. You've got to be careful. A lot of students make mistakes. If it's negative y, or negative x, when you're using substitution, you have to remember to distribute this negative symbol to all of these terms. So we have a new equation now. When we rewrite the 3x minus y equals -2, we're going to rewrite this as, do I have room? Oh yeah, plenty of room. 3x minus parentheses, all this stuff, x squared minus 5x minus 7. Okay? You want to make sure you're subtracting the entire quantity. So you've got to distribute the negative to all of these. They're all going to change sign, all right? And then we have equals and then -2. So now we have an equation with just x's that we can solve. It's quadratic, so we'll solve it probably by factoring or by the quadratic formula, okay? So we would now distribute the negative, 3x minus x squared plus 5x plus 7, right? Distributing the minus to all of these, okay? Is -2. And now we're solving a quadratic. As always, you want to get one side equal to 0. I'm going to make the left side equal 0. It seems easier just to add the 2. But I like dealing with a positive x squared term, a positive x squared term. So, it's personal preference. Okay, you could just like add the 2 and then divide everything by -1. That's fine. Okay, but just get that x squared term to be positive. It'll be easier to work with. So, because I think I'm going to run out of room here, let me add the 2 over here. So we're left with 0. So we have plus 9 now, right? 3x and 5x make 8x. And then we have the -x squared, right? So just collecting some like terms, adding the 2 and collecting like terms, we get this. I'm then going to divide everything by -1 to make that negative quadratic, or make the quadratic coefficient positive. So we now have positive x squared minus 8x minus 9 equals still 0. And as you can see, you can factor this pretty easily. Right? The lead coefficient is 1, so these problems are easier to see if you can factor. So we're going to have x minus 9x plus 1. Again, you could use the quadratic formula, but that just takes a longer time. There's more room for error, and you have to then simplify the fractions at the end. Right? Here it's easier. X equals positive 9 and negative 1. Okay. Now, those are not the answers. Don't forget, when you're solving a system of equations, and those are the instructions, even though they're not written, is to solve this system, right? I'll write that. Solve the system. Solve the system. Okay, so that's more like solve the system. Anyway, we have these two x values, right? So our solutions are going to be 9 comma something and -1 comma something. Right? We solved for x's. So these are just the x values where the two graphs meet, where the parabola meets the line. Okay? We've got to find the y values now, and just like we did with linear systems, we just plug in those x values into either equation to get the corresponding y value. So we want to plug in 9 and -1. Which equation is easier to work with? Probably the linear one, right?